If once isn't enough, watch it again. All right, so here we go. Number one, sketch this without plotting points and without your calculator. This test will be part calculator and part not. Okay? As you do the review sheet, you will see there it's divided up too. But this says specifically no calculator, and we're going to sketch this. F of x equals x minus 3 plus 2. This should not be an issue for you. This is an absolute value, so what is the shape going to be? A V. What does this minus 3 and this plus 2 do to the V? Takes it right 3 and up 2. So you're going to have your regular old absolute value V, but it's Ving from the point 3 comma 2. Would everybody agree with that? So now the question is, oh, that's it. That is the whole question. All right, we're done. Easy. All right. Is f of x equals the absolute value, odd, even, or neither? All right, so let's think about the absolute value function. We just talked about what it looks like, right? It V's from the origin. Even, odd, or neither? It is even. Why or why not? Or why? It's symmetric about the y-axis. If you folded it, it would double over on itself. The left and the right side of the y-axis are exactly the same. Everybody got it? We've talked about that about 12,000 times. Now, the next one. This is more recent material. Okay? So C of x equals 2x plus 1. H of x equals 9x squared. Oh, and Mrs. Ford got tricky. S of x equals 2. We're going to find C of H of S of 4.
Mrs. Ford, do you have any raffle tickets?
I do not.
Yeah.
I'm sorry.
Friday's next collection.
Okay, I'll try to remember what period to collect from. All right, so we're going to find C of H of S of 4. Now, you're thinking, Miss Ford, that's not fair. We've never done that before. Yes, we have, but we didn't do it with 3 functions before. But the idea is the same. This says C of H of S of 4. So S of 4. That's where we're starting. Read it. C of H of S of 4. S of 4. So we're going to come over to our S function. This is the tricky one. What do you get if you put a 4 in there for x? What do you get? You don't get 4 equals 2. You get S of 4 equals 2. What's S of 5? 2. What's S of 18? 2. This is what we call a constant function. No matter what you put in, the only answer you're going to get out is 2. So S of 4 is 2. Anything you plug in is going to give you a 2. So this part of the problem, S of 4, is 2. So now what are we doing? Now we're finding C of H of 2. This is 2. So now it says find C of H of 2. All right, so what does that mean? H of 2. All right, so what's H of 2? Watch your order of operations. 36. 9 times 2 squared, that's 4. 9 times 2 is 36. So this H of 2 is 36. So now what are we finding? C of 36. And C of 36 will be 2 times 36 plus 1. So what did we do on that problem? We plugged 4 into S and got an answer. That answer got plugged into H. And then that answer got plugged into C. If we had 5 functions, we would do the same thing. 4 goes into S, That answer goes into H. That answer goes into C. And you just keep working backwards. Max?
So even if, like, let's say S of X would have had like 2X or something, you would still keep it in there just like.
Oh yeah, it wouldn't make a difference. If that had been 2X, then when I put in my 4, I would have gotten 8. And then the 8 is the number that would have gone in here.
Oh.
And then I got a different number that would have gone into C. Yeah, the output doesn't matter.
Oh.
Alright.
No, just.
Now we're going to talk about a piecewise function. So we did these the other day, and there's some in your homework. All right, so here we go. What's that top function? What shape is that top function? Remember, this is the equation y equals x plus y. It's a line. It's a variation of the identity. In fact, it's the identity lifted up one. So instead of being, okay, my picture's gonna get really cluttered here, but there's the identity, right? If I lift it up one, I get this. Would you agree with that? Now, if you don't want to think about it like that, that's fine. This is the line whose y-intercept is 1 with a slope of 1. So you could graph it that way too, if that's easier for you. Okay, but here's the deal. That is the whole line. And I only want the part of the line where x is less than -2. Now, where on that line is the point where x is -2? Well, if you put in -2, you would get -1. So that's this point right here. That's the point -2, -1.
Do you erase these?
Well, I need to erase part of it. Which part am I going to keep and which part am I going to erase? I want x's less than -2. So I'm going to keep this part, right? I'm going to extend it a little longer. I'm going to keep that part, and I'm going to get rid of this. And there's one more change I need to make. Can you see what it is? It's an open dot. Yep, so that dot needs to be opened up. That's an open dot. Because the -2 is not included. Who's missing over here? Clara. Okay? Now, let's take a look at this next one. What's this second one say? Y equals 3. What's that? What's y equals 3? That's your horizontal line. There it is. There's the whole line. Now, do I want the whole line? No, I only want the part of the line. Oh my goodness. I only want 1 point, because I only want the part of the line where x equals -2. So that would be right here. That's the point I want. I want the 1 point on that line where x equals -2. So I don't want any of that, and I don't want any of this. This time I only want the point. It says x equals -2. Right? What shape is this? It's a parabola, right? And I'm going to go ahead and make this a little bit more careful than I normally do. So there's that side of it. And here's this side of it. Now, I don't want the whole thing. What part of that parabola do I want? All the places where x is greater than -2. Now, if I put -2 in this, I get 4. So -2, 4 is a point on this graph. And I'm going to open it up because it's not included, right? Now, do I want this piece of the parabola, or do I want all the rest of it?
All the rest.
I want all the rest of it. So there's a picture of your piecewise function. Very strange looking.
So the ones on the test be similar to this type?
Uh-huh.
Do you always plug in the number of the inequality? How do you get your point?
To help me find my point, yeah, so I know where to put it. Now, the other ones we looked at had the origin as, the break point here is -2. This is where the picture's broken at -2. The other ones we looked at had a break point at 0, so it's a little bit easier to tell, like that point was right there, obviously. Well, when I can't tell what it is, I want to figure out where to put it, that starting piece there for that curve. Now, along with this, I didn't ask it here, but I'm pretty sure I will ask about domain and range for this function. So what would you say about domain? All reals. You have covered every base with your x's. All real numbers. Now watch your range. Be very, very careful. Very careful. What's your range? Negative infinity to -1. That takes care of this, right? Remember, range is which coordinate? Y. So I'm looking at the y. Negative infinity to -1. Okay. Or what? 0 to infinity. And am I going to include the 0? Yep. It's part of the curve.
Wait, why did 0 get a bracket?
Because it's included. That point's colored in. The origin is included in the picture. Okay, now number 5. What's the domain? All right, here we go. Look at problem A. Do you see a radical? Here come the domain radar, because what's wrong with a radical? No, there's no hole. Well, what do we know about radicals? Whatever is under them has to be bigger than or equal to 0. So, whatever is under the radical, which is 3x plus 5, has to be bigger than or equal to 0. Which means x has to be bigger than or equal to -5/3. That's your domain. What about b? What about the function h of x? What about that function? What's your domain? All reals. Why is the domain for b all reals? No radical, no denominator, no problem. Unless it's something funky like a logarithm or something weird. If it's just a regular function, no radical, no denominator, no issues. All real numbers. What about C? S of x. X doesn't have to be greater than. X does not equal 5. When you have denominators, you don't care if denominators are positive or negative. You only care if denominators are 0. So your domain is x is not equal to 5. And those are the ones that I told you, you can write x is not equal to 5. Or you can be supreme mathematicians and write it like this. Doesn't that say the same thing? It's just a bunch more writing that you can do or not do. But recognize that is the mathematical way of expressing this. For number 3 above, so I'm going back up to number 3. What is the domain of C plus H? Okay, well, first of all, what would C plus H be? C plus H would be what? 9x squared plus 2x plus 1? Do you see a radical?
Yeah.
Do you see a radical? Do you see a fraction? Therefore, what's your domain? all real numbers. There is an example of a problem that looks so complicated, but it is so easy. What is the range of the identity function? Oh shoot, I didn't realize the answers were right there. We should be folding this over so we're not seeing it. What is the range of the identity function? All reals. Doesn't the identity function, isn't it continuous all the way down, all the way up? What is the range of the absolute value function? I erased it, but what's the domain of the absolute value function? Not domain. The domain is all reals. What's the range? 0 to infinity. Y has to be greater than or equal to 0. Think about it. Isn't it bounded below at 0? Your absolute value? Sketch the cubing function. What's the cubing function look like? Squiggly through the origin. That's your cubing function.
Did we do number 6? Oh yeah, we did.
We did. We did all those because we are so good.
Yes.
All right, turn it over. Oh my gosh, extra review.
Let's go.
Now, let's fold our paper so we only see the half with the problems and not the answers. And let's talk domain. Okay, so we've got 3 functions, or 4, I guess. We got F, G, H, and K. So, who can give me the domain of any of these? They're definitely hard ones and easy ones. Who can give me the domain for any of them? Jason?
For X cannot equal 2.
X cannot equal 2? Negative 2. Because the denominator can't be 0. But wait a second. We have double trouble in that problem. Because what are the 2 red flags? Radicals and denominators, and we have both. So, good start. X cannot be negative 2. That takes care of the denominator, right? Jack? You know what? I gotta figure it out. I don't even know. So I'm gonna, probably, you're probably right. I can't figure, I don't know. At 5 minus 3x has to be greater than or equal to 0. Remember, whatever is under the radical has to be greater than or equal to 0. Because it never changes. It's always, that's the rule. So 5 minus 3x, positive. So I'm going to subtract 5. And then I'm going to divide by negative 3. And just like you said, Jack, that's going to turn that around. And so x has to be less than or equal to 5/3. Now, you are free to write that. Now, they both have to be there. You need both things. But you're free to write it that way. Or, you could say, negative infinity to negative 2. Or, negative 2 to 5/3. What about this one? Domain. X cannot be negative 1/2. Very, very good. And that's good enough. You can write it in interval form if you want, but that's good enough. Why can't X be negative 1/2? Because your denominator can't equal 0. In domain world, there are 2 things I worry about, Cassie. What are the 2 things? Denominator can't be 0. Anything under the radical has to be bigger than or equal to 0. Okay? So the numerator, I don't even worry about it unless it has a radical. Then I gotta worry about it. What about H? All reals. What about K? No! It has a radical in it. Oh my gosh, what do I have to do? If there's a radical, whatever is under it must be greater than or equal to 0. So x has to be bigger than or equal to -2. Okay? So one more time. One more time. See how this hair is getting greater by the minute, you guys. If you have a denominator, it cannot be 0. If you have a radical, whatever is under it must be greater than or equal to 0. Those are the 2 rules. That's what you got to know and do. If you don't have either one, then it's all real numbers. All right, I'm going to try to calm down. Number 2. Even, odd, or neither. This is strange. What does the notation f of 4 equals -2 mean? F of 4 equals -2. What does that correspond with? What's 4? X. What's this? That's the answer. That is your y. So this is the point for -2. This notation is simply function notation that says, okay, if you plug in 4, you will get out -2. If you let x be 4, your answer or your y will be -2. All right, so 4 -2. So there's that point. Now, what's the other point? F of -4 is -2. So that would be -4, -2. So -4, -2. And that's all you got is those 2 points. So based on that, would you say this is even, odd, or neither? Even. Why? These guys are reflections of each other across the y-axis. Now, if this had been the first point, and this had been the second point, then we would be reflections across the origin, and that would be odd. If this had been your first point, and this was your second point, then it would be neither, because it's not across, it's not across y or the origin. Got it? Yeah. Yes, we can. Let me do one more, and then we will. Yes, we'll do that. Let me do one more. Okay. Actually, this has got a ton of parts, so I'll just stop there. Somebody kind of keep track. That's where we are. And if we need more review, we can start there. All right. What homework questions do you have? I need a like a section number and a problem number. 1, 1, 1, 1. Number which one? 42 is a calculator problem. So this is one of our calculator problems. And while it isn't going to matter to me how you do it on your calculator, I like the way they suggest in the directions, which is get it set equal to 0. So I'm going to do that. I'm going to get my equation set equal to 0. And then when I graph it, once I have it equal to 0, when I graph it, what will I be looking for? Where it crosses the x-axis. Okay, now I have no idea how my window is set. I'm not going to worry about it right now. I'm going to put in this equation. What? No, it's this right here. I brought it over here. Okay, so I have 2 radical. just gonna graph it and see what happens. Now, I don't know how your window is set, so I don't know what you're seeing. I'm gonna show you what I'm seeing. I'm seeing something that has, it's like this little arc thing, and it does cross. So this would be the point I'd be looking for. But it has, it looks like on my calculator, it has a definite start and stop point. It does, and I want you to think about that. Look at this radical right here. What can you tell me about x? It has to be greater than or equal to -6. So that starting point is -6. What does this radical tell me? Well, when they're turned around like that, it's hard for me. So I'm going to say that has to be positive. So what does that say? Oops. -5. So that says x is less than or equal to 5. So guess what this point is right here? 5. This domain is bigger than -6 and less than 5 because of the radicals. So that's it. That is the whole picture. So how do I find the point I'm looking for? Second calc, go to 0, left bound, right bound, and get my answer. You've done that a million times. Nothing tricky or hard about this problem, except typing it in. So this is 2.664543. Okay, that wasn't so bad. Who else has a homework question?
48.
Same page?
What number was that?
That, I don't know, that was something on page 83. Now I'm doing 48. 48, the pictures are already given.
What number are we doing?
48.
Same worksheet?
Same, well, it's in the book. Same set of numbers, yeah, same set of problem section. Okay, so I've got these equations. And let's see if I need the calculator to do this or not. Let's see. So I got these three functions. Now, can you tell us, yeah, in my book, they're black, blue, and red. Are yours? Okay. So the black one is clearly the line, right? The red one is this one, and the blue one is this one. Now, how do I know that?
Oh, because one's negative.
One's positive x cubed and one's a negative x cubed. Now, stop and think for a minute, your BFFs. This is a positive x cubed, right? Which direction does a positive x cubed go? Up. So of the two curvy things, the blue and the red in your book, which one is ultimately going up? The red. So that's how I knew that one was the red one, because it's a positive x cubed. So the other one is the blue one. Okay, so the problem says, write an equation that can be solved to find the points of intersection of y1 and y2. Well, if you want y1 and y2 to intersect each other, you want them to be equal. So we'll just set them equal to each other. So there would be an equation that would find where they intersect. Where they intersect is where they have the same value. Okay? Now, if I were going to do this, I would move everything over and get it set equal to 0. You don't have to do that, but that's how I would do it. I would type this into my calculator, and wherever it crossed the x-axis, that's where it would cross. Okay, so that's A. B says, oh wait, so this could be A or B. Really, A and B are the same question, because won't this find the x-intercepts for me? Isn't that how I'd solve that? Yeah, so A and B are really the same question. C says, how does the graphical model reflect the fact that the answers to A and B are equivalent algebraically? Well, if you graph this and you graph this, they would be the same. I mean, they are the same equation. I don't know, it's kind of a dumb question. Confirm numerically that the x-intercepts of y3 give the same values. Okay, look at y3 and look at the answer we got to A and B. What do you think about these two equations? Well, they aren't, because if you solved this one, if you were solving this one, you would set it equal to 0 and find its x-intercepts. Could you divide this one by a negative and end up with this one? Yeah, so they're the same. They're exactly the same equation. The x-intercepts are the same. These have the same x-intercepts. Because if you divided this by a negative, you'd be left with the same equation. They have the same x-intercepts. Okay, all right, who else has a question about a homework problem? Same page, 51. Oh, we already did 51. I did it in class. Anybody else have a question?
On the same page.
Same page, 18. 18. Explain why the percentages cannot continue indefinitely to follow the linear model you wrote in exercise 15. All right, well, what was the equation you wrote in exercise 15? What was that equation in 15? Y equals what?
I don't think I did it right, so that might be wrong.
Okay, I don't know how you could not do it right because your calculator did it for you, didn't it? Yeah. Oh, well, no, you didn't have to, because 15 says use 54 and 99 as ordered pairs. So you could have done it by hand. Who's got it? Who's got the answer to 15? Okay, boys and girls, I'm not doing it, and I'll tell you why. I read question 15. It says use the 1954 and 1999 ordered pairs to compute the slope and write the equation of the line. Should we be able to do that at this stage of our lives? Yes. I'm not doing it. So I am not going forward with this problem unless somebody can tell me the equation you got when you did it. Somebody should have it done. Isabel. 0.58x plus 32? Plus or minus? Minus 32. Plus 32.
For the men's, I got y equals negative 0.211x.
Am I supposed to be using mens on this?
Yes.
Okay, so what is the right equation? You're saying Max, this isn't right?
Oh no, that one's the one that I got.
For the women? Okay, what'd you get for the men?
For the men, I got y equals negative 0.211x plus 83.5.
Okay. All right, so either one, I don't know which one I'm supposed to be talking about, but either one, think about these two lines. This one has a, which is the women, has a positive slope, looks like this, right?
Yeah.
Now, what does this, what do those ordered pairs, when you wrote your equation, what did the x represent? The first things, what did they represent?
Years.
Years. So you had years. And what did the y represent? No, it wasn't male to female. It was, wasn't it the percentage of people working? Yeah, that was it. It says in the problem, that's what it says. Now, look at this line. This is just the women line. The same would be true of the men line, except the men line's going the other direction. But you said x's were years and y's were percentages. Okay, notice that the line just keeps going forever and ever and ever. What is the highest value this could ever be? 100. Does that line stop at 100?
No.
No. So what's wrong with the model?
It goes past.
It goes past 100. Furthermore, what's wrong with the model on this end? What would all this mean? Negative years and negative percentages? So the model is good, but only for like this section of it, right? The rest of it doesn't make any sense. And that's okay. I mean, that happens. You got to keep it in perspective of the problem. Okay, Brooke?
On 36A.
All right, last one. I'm going to 1-3, and I'm doing 36A. 36A says sine x plus 5. Well, first of all, let's just look at sine x plus 5. And then we have to answer questions about it. Okay? So, by test day, everybody needs to be able to sketch your sine curve with the appropriate labels. Okay, so that's straight off your BFF sheet. That is the sine curve. Now, we want to take that sine curve and, this is 36, add 5 to it. Now notice, it doesn't say this. That would be something different, right? What does that mean? What do you do with a plus 5 on the end? Up 5. So I'm going to have a picture now. I'm going to move it up 5. So 2, 3, 4, 5, 6. So there's 6, there's 5, there's 4, there's 3. So everything is going up 5. So instead of oscillating across this line, it's going to be oscillating across 1 5 units up. Would you agree? So I'm going to have my regular old sine curve, but he's up here. His low point would be at 4, and his high point would be at 6. Everything got moved up 5. All right, so that's the picture. What are the questions? On what interval is it increasing or decreasing? Well, when we say on what interval is it increasing or decreasing, there are tons of them in this one. So we could say from 0 to pi over 2, it's increasing. Would you agree with that? And then from pi over 2 to 3 pi over 2, it is decreasing. And then from 3 pi over 2 to 2 pi, it is increasing again.
Hail Mary, full of grace, the Lord is with you. Blessed are you among women, and blessed is the fruit of your womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death.
Now, one thing I want to point out, I just kind of looked ahead. Sorry about that. Now, this is not even or odd. It's neither. I know the regular sine function is symmetric about the origin, but here's the origin. There's pieces here and pieces here. For the green curve, we have pieces in quadrant 1, but do we have pieces to match it in quadrant 3? No, the 5 messed everything up, so that has no symmetry. All right, no symmetry. With your sines and cosines, when we talk about increasing and decreasing, remember, you have to limit yourself. Otherwise, you just go forever. All right, have a good day. Homework due Friday.
Miss,
Maggie, can you turn it off?
do you remember, we just